longer just buzzwords. They are shaping the future of the world, from self-driving cars, healthcare diagnostics, fraud detections, recommendation systems, to space research and missions at NASA. AI and ML are transferring how decisions are made, problems are solved, and innovations are built. So, to guide us through this exciting journey of AI/ML with a global exposure, we are truly honored to have Ms. Aishwarya with us today. She holds a Bachelor of Engineering in Computer Science and is currently pursuing her Master's in Data Science and Artificial Intelligence, and brings a strong blend of technical, corporate, and leadership experience. She has worked as a data science intern in data AI software solutions, gained corporate exposure as a business development associate at IntelliPad, and is presently working as a software developer at Oliver. In addition, she has also served as the corporate head at Vijesha ID Services LLP, playing a key role in bringing industry, technology, and student growth. Her journey is perfect, reflecting how AI, ML, and data science can open doors across multiple domains. And today, she shared those real world insight with us today. So without any further delay, Miss Aishwarya, the stage is all yours. Are you in?
Yes, in and thank you so much, Tasneem, for such a nice introduction, and a warm welcome everyone to this webinar. So I hope you will enjoy this webinar. And before going to that, I want to ask something, like how much you people are interested towards this webinar? How much you people are pumped up? I want to see the excitement. Is there any kind of excitement under you? Yes, yes,
Yay!
I get. Yes, fine. So I think, like, yes, there are so many students who raise their hands, and thank you so much. And I guess, like, so many students are interested only towards this AI/ML at NASA. Yes, obviously. So the artificial intelligence is used all over around your surroundings. It is used, and why not? It is not being used in the space, right? So the NASA is the first company, I mean, the space research organization where they have used this AI. Then after comes the ISRO. So ISRO is the one more space organization where they have used this AI, and that's the reason where the Chandrayaan 3 has become more successful compared to the Chandrayaan 2. So before beginning to this, all the AI with NASA and AI/ML, so before going to that, I just want to say that yes, the AI is used everywhere, right? Yes or no? There should be interaction in my webinar. You people can't sit quiet. You just unmute yourself and can say, yes, the AI is used everywhere, right? Yes or no? Kindly unmute yourself and you can answer.
Just
The AI
no.
is
Ma'am.
used.
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes,
Yes,
ma'am.
Yes, ma'am.
Yes,
Yes, ma'am.
yes.
Yes,
The AI
yes,
is
ma'am.
yes, ma'am.
yes, ma'am. Yeah, yeah.
Yes, ma'am.
Okay, I understood. So the AI is used everywhere, right? So it is not something like we are not using AI. Yes, we are using the AI in even the mobile phones also for the face unlocking, and also we are using the AI in the Siri, Alexa. Everywhere we are using this AI, right? So my one simple question to you people: what do you know this? What do you mean by this AI/ML? What do you mean by this artificial intelligence? Any idea about this artificial intelligence?
Advanced technology.
We can say that it is a software
Meow.
created by
Okay,
humans to make their work more easy.
okay. So apart from that, Any other answers? Like, what do you mean by this artificial intelligence?
Basically,
No
we can
need.
see that people used to make programs by AIs and coding.
No need of experience to do
Mhm.
work.
Mhm.
AI is a
Very good.
technology that makes machinery.
Smart work in software
Kind
engineering.
of
Tell
computers.
one by one, no? Tell one by one. I'll not understand if everyone comes. Tell one by one. Yes, what do you mean by this?
No need of experience to do work.
Ma'am, it works. It makes work easier
So,
and human, ma'am.
okay, the
It
AI
cannot
will
take.
work to make.
It works 100 man works only one.
The mission can make decisions and predict.
Okay, fine. So now you people know this AI will make the work easy, right? To make the work easy, the AI engineers are required, right? So that is what this webinar is kept. So this, what is this artificial intelligence? So let me tell you this. This is the something where I can say we are making the machines smart so that they can think, learn, and they can make the decisions like human. This is the only simple way where we can define the artificial intelligence, right? So where we are making the machines to think like a human, to act like a human. So for example, if we give the example of the Siri, so if I say Siri, please on the torch, if I say for that, so it will on the torch, right? So if I say for the normal person, please on the torch or please on the light, what he will or she will do, she will on the light, right? In the same way, we are uh, giving the datas, we are training the machines to act and think like a human. That is called as your artificial intelligence, right? So it is the just example. If we give Siri is the best example, and one more is Alexa. So if we say Alexa, please sing the song, the Alexa will sing the song, right? So this is the one thing. And one more thing is that the self-driving cars, your the Tesla cars. So the Tesla cars are the best example for this. And the one more thing is the Mars rover. So which we will be discussing further in 20 minutes or in 15 minutes. So this is the basic example of this artificial intelligence. So then I'll just share the screen so that it will be easy for you. Yes, my screen is visible, right? Yeah. It is visible or no?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Visible.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. Visible.
Yes. Now we
Yes,
are
ma'am.
going to see what is this artificial intelligence. So again, I told you artificial intelligence, it is something we are going to make machines smart so that they can think, learn, and they can make the decisions like a human being. Right. So here again, the artificial intelligence, it refers to the capability of the machines to imitate like a human being or the human behavior. So next, what are the key characteristics of them? First of all is the perception, where it can recognize the speech, images, as well as the patterns. Next is reasoning. So reasoning, where we will be solving the problems using this logics and all. Then next is learning, where we are going to improve the performance through the experience. So what are the types of AI? We have the narrow AI, general AI, as well as the super AI. What is this narrow AI? So narrow AI is something we are going to do typically only the one task. So for example, we can give is the GPS. So from source to the destination. This is the only one task which will be done, that is the narrow AI. Then next is the general AI, where everything will be used, this general AI. And next one is the super AI, where it typically it is like the robotics, where it will surpass the human activities. So we are in which era now? So basically, we are in this narrow as well as we are in the general AI era. So we should go to this super AI when the time consumes more in this artificial intelligence. So this is the thing. What about the artificial intelligence? So next is, what is this machine? Yes, obviously, it is a heart of this modern AI. So, what is the simple definition of this machine? Yes, machine learning. It is a part of the artificial intelligence where machine learns from the data instead of being typed to programmly. It is typed. Instead of that, we are going to give the data for this. For example, what I'm going to do is, can you see this object? What is this? This object? Everyone are there in the webinar, right? So what is this object?
The bottle.
Water.
Bottle.
And it's a
Toy.
Doll.
Bottle.
Toy or doll.
Toy. Doll.
Ball, right? This is bottle.
Toy.
So this is
This is a bottle and this is a toy.
yeah, I got it. This is the doll as well as this is the bottle. So what I'm going to do for the machine? So basically, I want to train the machine such that if I keep bottle in front of that, the machine should be able to tell this is the bottle. So if I keep the doll in front of this, we are going to say, yes, this is the doll. Which kind of doll it is? What kind of doll it is? A Tweety bird, which is seen in the Looney Tunes, right? Looney Tunes cartoon, see or no? I hope you people will not see the cartoons or anything. That is fine. So here what it is happening is in this machine learning. So what kind of data? So basically, the bottle is cylindrical in shape, is long, and also this has the cap. Okay, and it has a hollow. So these kind of data I'm going to give the machine. And what I'm going to do, I'm just going to keep it in front of the machine. So the machine will detect and it will check which all kind of data are present. The bottle is cylindrical in shape, check. It is long, check. Then it has a cap, it is check. If everything is checked, then what it gives, it will detect everything and it will give you the bottle. And in the same way, the doll is given right here. So here in the doll, what I'm going to do, the doll has this hands and it has the legs as well as it has the small nose. So if these things are there, and if this looks so similar, the face is enlarged, the body is small, and the legs are very big. So then what I'm going to do, it is from the Tunes characteristic. It's going to identify this is a bird, right? So it is going to identify this is the Tweety bird. But there are some other dolls also, right? So they are going to use the bag. I mean, if we if the dolls will be having bag, and if the hairs are long, just going to keep the same thing, and the machines are going to detect this is the doll, this is the bottle. And even the most famous example is the what I can say is the dog is also best example for that. How they are going to detect the dog by if it has the tails, if it has the 4 legs, and even the cat also, how the cat is going to be, it will be having the tail, mustache, and the ears are up. So these all kind of datas, if we are giving to the machine, what it is going to do, it will detect that, and it will give you, yes, this is the dog, this is the bottle, this is the doll. So this is how your the machine learning will be working. So basically it will take the historical data, then the mathematical algorithm will be happening, then the output, it will predict the image, which is the image or the classification what we want to make. So the best example is that predicting the house prices and detecting the spam emails, detecting the objects. So these are the best examples for this machine learning. So the next one is, what is this deep learning? What is this deep learning? So deep learning, it is a part of machine learning that uses the artificial neural networks, that you will be learning from the large amount of data, right? Here it will be using a multi-layered neural networks, which is inspired by this human brains. So for example, here I can give the face recognition, which will be there in the phone, right? So you people will be using your face to unlock, right? So the first layer, what it happens, in the deep learning network, the first layer, it detects the edges of the particular person. Then in the next layer, what it happens, it will detect the eyes, and it will detect the nose, and it will detect the eyelashes, lips. So these all happens in the second layer. So next, in the final layer, what it happens, it recognizes the face, and then your phone unlocks, right? So this is basically about this deep learning. So before going to this next, we have this types of machine learning. So can you just tell me what are the types of this machine learning? What are the types of the machine learning?
Supervised learning, unsupervised learning, semi-supervised
Supervised
learning, and
learning, unsupervised
reinforcement learning.
learning, semi
Supervised
semi
learning.
Supervised learning.
Okay, fine. So we already, you people know about the types of machine learning. First of all is the supervised learning. Then next we have the unsupervised learning. Then next we have the semi-supervised learning, and the fourth one is the reinforcement learning. So what is this, the supervised learning? What is the simple definition? You're going to learn from the labeled data. Whatever the data we are giving, we are going to learn from this, the labeled data. So for example, if I say is that I'm going to take a apple as well as the strawberry. So these are the best example. What are the characteristics of this apple? The apple is round in shape. It is red in color. The seeds are inside. So what about the strawberry? Strawberry is diamond in shape. Seeds are inside. It is also red in color. So these kind of datas have been already given to this, and it is going to detect whether it is a strawberry or whether it is a apple. It is going to detect. And the techniques what we are going to use is that the linear regression, decision trees, as well as the KNN algorithm. So what is this unsupervised learning? So here, unsupervised learning, you're going to learn from the unlabeled data, and here we will be using the algorithms that will try to find the hidden patterns. So here again, the techniques which we are using is the k-means clustering as well as the hierarchical clustering. So these are the two techniques which we are using. So next we have the semi-supervised learning. So here again in the semi-supervised learning, we will be having a mixed label and unlabeled data we will be. So the technique is they are going to self-train them. They will be using a multi-view training as well as the graph-based methodology. So now you will be asking like, what is the example for this unsupervised learning? The customer shopping, we are going to do the segmentation. So here the girls are what they are going to do. They are going to buy the lipsticks. They are going to buy the dress. But boys, what they are going to do, they are going to buy gadgets and all. Gadgets, shoes. So, but everything comes under the one segment, that is the customer shopping segment. Okay, but here what we are going to do is that we are going to segregate that girls shopping is, which is the unlabeled data and which is the clumsy data. Okay, the customer shopping. So here what I'm going to do is that just what all girls are taking, I'm going to segregate that, and what boys will, I'm going to segregate that. So this is how your the unsupervised learning will be working. And next we have the reinforcement learning. That is, you're going to learn through the trial and error method. So the techniques which we are using is the Q learning. And the example for this is the robotics. Robotics is the best example of reinforcement learning. So this is all about this AI. Now we are going to see how the NASA is using this AI in the action of this autonomous Mars rovers. So before going to this autonomous Mars rovers, I'm just going to ask you the simple question: what rovers? What is rover? What is rover?
We can say
So
rovers
it's
as
traveling around
that
Mars.
landed to another planets for the purpose of exploring.
Even robots uses AI for navigation.
That is
which
true.
Yes,
which
ma'am.
helps to eliminate the rocks in the space.
Even robot uses AI for navigation.
Robotic
The machines
vehicles.
which explore other
It
planets.
uses signal to know where it has to be avoid, and with AI help, it can do that.
Even robot uses
It is a
Ma'am,
technique
robots
which
uses
gives the
AI
signal.
to problem
Rover is a
navigation.
technique
It
which
is an
gives the signal from one planet to the Earth.
It is an organization
It is a robot
which gives the
vehicle.
It's an
signal.
it is an
organization.
robot organization.
Okay, so now we are going to see basically what is rovers. So you gave me the multiple answers. What is rovers? Where this rovers are used and all. So just going in a simple definition, what is the space rover? So basically, the space rover, it is a vehicle which will be having the wheels and other sensors, and the cameras will be used in this rovers, which we are going to explore the surface of planets. We are going to explore the surface of the moon and other celestial bodies. So in that case, we are using this rovers, right? So what we are going to do is thus that the auto nav system. So here the rovers are using this auto navigation system. The Mars rovers, like, it will be curious and perseverance, and it is AI driven. Okay, so then next we have that is there is some algorithm which is used. We are going to see in the further part. Okay, the most famous algorithm is the Aegis algorithm. It selects scientifically interesting rocks formations as well as the geological features, photographs. So these are which is the algorithm which we will be using, and it will select and it will take the picture of that. So the next we have the real-time decisions. Yes, obviously when the AI is there, so the real-time decisions will be. So if there are some critical conditions which will be there. So if it is like a terrain, what is mean by the terrain? A piece of land which is there in the planet. Okay, the small piece of land which is there in the planet. So to just to capture that, and whether to check that is risky, dangerous, or it is safe, to check that the real-time decision. Okay, so this is called where the NASA will be using this AI. So before going to that, then next we are going to see this. What are the key features of this autonomous Mars rover? So the first thing is that the navigation and the path planning. So the biggest challenge for these people is, you might be thinking, right? So like the Mars rovers, we cannot use it with the joystick. Joystick, you understand, right? The way you will be playing with this video games, and so the Mars rover cannot be controlled using this joystick. That is the one thing. And one more thing is that from Earth to Mars, we are even sending the commands also. It will take hours together to reach that command. And that is why the Chandrayaan 2 got failed, right? What happened in Chandrayaan 2? Suddenly, just 1 minute. Just 1 second. Okay, so now the biggest challenge is that you will be not able to give commands from Earth. This, what I can say is that to the Mars, right? So here what happens, even though the people are giving the commands, but it will reach hours together, right? So that is why the Chandrayaan 2 got failed. Yeah, obviously it got crashed, right? So that is why it got failed. So that is the reason what they have done. They have used several algorithms also in this. So this is the one thing. And one more thing is that simply the rovers will go. Even the terrain has the risky, whether it is a danger or anything, simply it will go off. So these are the biggest challenges. That's the reason where they have given this autonomous rovers. Okay, so this is the one thing. So what I can say is that the rovers it has obviously the eyes. So what it sees in this what it sees in the terrain, that is the piece of land. First, the one is the sensors. So here the sensors as well as the cameras will be used in this rovers. So first of all, which type of cameras they have used? That is the one question, right? So the one is the NavCam camera as well as the HazCam camera. So these two cameras are used to take the 3D pictures as well as to measure the distance between the slope. So that is the reason where this stereo cameras are used. even the rovers should understand, right? So what is there, what is not there. So that is the reason where the cameras are used. So the next one is that IMU, that is the inertial measurement unit. So here what it happens, it will measure the acceleration and the speed of the rovers. That it is going to do. And next is the wheel odometry. So here wheel odometry means what? Obviously the rovers is having the wheels, right? So they have fixed some of the sensors. So what it is going to do, it will track how far the wheels will move or not. So then afterwards, what it is going to do, the rovers will understand whether it is a rock, whether it is a slope, whether it has some holes or anything like that. The rover will understand by just capturing the pictures. Okay, then afterwards, what it happens? It will map the environment. How it map the environment? The rover, what it does, it will build a local map around itself. So, for example, we will take is that after like 2 kilometers, there will be one rock. Okay. So here, what happens in the rock? The rover will be going to take the picture of the rock. Okay. So what it is going to do? It will make in the form of the pictures. That is the small grid cells, your pixels. Okay. So each cell, what it is going to do, they are going to label it as whether the particular place is safe, or it is a risky, or it is very dangerous. So these three kind of things it is going to label. Then afterwards it will move forward. Right. So this is how the mapping will be happening. So then after what it is going to do, the path planning will be happening where they are going to choose the best route. So here it includes the algorithms like the A star algorithm, D star algorithm, Vijesha algorithm. So these kind of algorithm will be used so that what it happens, you can reach to the possible and the safest route. Right. So if it is the dangerous route, what you are going to do? We are going to check even that also, right? So that is the reason. So these kind of algorithms we are to use in this, so that it is easy for the rover also to reach the safest place. So how this rover will decide? So it is going to decide by the distance and the energy usage. These are the two things where they are going to use. So this is all about the navigation and the path planning. So then next is the perception and the sensing. So what happens in the perception and the sensing? Sensing means it is going to collect the data, raw data, by the rovers will be using this multiple sensors. That is the stereo cameras. I hope you have heard about this nav cam and the has cam. I have told you 2 minutes before only. So these two cameras are used to take the 3D images, and again the IMU, that is the inertial measurement unit for measuring the acceleration speed, as well as the wheel sensors to track the distance move, as well as there will be some other sensors called as a lidar and the radar will be using to detect, and it is going to sense what is happening. So what is the main basic thing of this perception? So perception means you are going to understand the data, whichever data you have collected, right? The images from the camera, sensors, these all things you have, collected these all data. So we are going to understand. So how it is going to understand? It will convert your stereo, which is taken from the camera, into your 3D terrain map. Terrain map means what? A piece of land that they will convert that into map. And it will identify, yes, this is the top, this is the slopes, this is the hole, this is the sand. So it is going identify those, and it will classify the areas, whether it is a safe or it is a dangerous or it is too risky to go. It is going to classify that. Then afterwards, what happens? The process that those all the data will be processed and sent to the path planning system. Yes, there is one path planning system which is uh, inbuilt in this Rovers. So what they are going to do, it will pre-process the perception data, and it will be sent to the path planning system where it avoids the hazards and it will choose the safe routes. Okay, so this is what it is going to do in the and the sensing. So the third one is this autonomous decision making. So here the AI shines like anything. So here what it is going to do, the autonomous decision making will be happening in the rovers, where it will be having the ability to decide and it can act on its own without waiting for the instructions from the earth. Okay, so for example, what I'm going to give is that the scientists are there. So the scientists, what they are going to do is that they are going to send the high level command. That is that rovers, for the rovers, please go to the rock and study it, how the rock is there in the Mars. So here what it is going to do, the perception and situation understanding will be happening. So here the rovers will be using the camera, will be using sensors, as well as it will be using the terrain and all. It will detect the rocks, slopes, sand, and hazards also. And it will understand the current state, what is the thing and all. And next, the decision logic, where the AI starts, AI brain will be there, start working. So the rover evaluates all the options using this AI algorithms, that is your A star, D star, as well as the EGIS algorithm. So these algorithms will be using. Okay, and what it is going to do, it will check which is the safest path. And should I move forward or no? I should stop or I should take a round. It will check that, and it will check even the slope is steep or no, and whether the energy is sufficient or not. Where from North Pole I need to go to the South Pole, and I need to check the rock which is there in the Mars. So what I'm going to do is that I'm going to check these all kinds of things. Then from North Pole to South Pole, I should go. Okay. So what I'm going to do is that whether the energy is sufficient or no, these all thinkings will be happening in this rovers. That is the Mars rover. Then the which is the best safe way to go and reach to the South Pole. It is going to check. And sometimes, yes, if there are some other rocks or anything, the obstacles which are there, so what it is going to do, sometimes it will stop and again it will replan, again it will move forward, then it will reach to the South Pole very safely. So here continuous self monitoring will be happening, continuous pictures they will be taking the cameras sensing will be happening. Then afterwards what it is going to do, it will check the map, again it will check whether it is a safe place or no. These all things they will be doing in the seconds. These all things will be happening in this. So this is what I can say is that autonomous decision making. So next one is the energy management. So you will be having the question, right? So if the robots are how they are made. So even they will be using this solar cells also, because solar cells and the nuclear cells, batteries, these all kind of things they will be using. Okay. So here what happens in the solar cells, if it gets low, battery gets low, what I should do? From North Pole to South Pole, I'm going. Okay. If the battery gets low in the middle, what I should do? So these all questions will be coming, right? So if the battery gets low, whether it will stop or what, whether it will get crash, we don't know, right? So here the power sources will be checked. So here if the solar panels will be installed and radio stop power sources will be all, so that the batteries get low. Again, it will get recharged with the sunlight. Then again, it will move forward. So what it does, Rover, it continues a battery level, whether my battery is low or what, whether my low or what, whether I need to go to South Pole, whether this is sufficient or no. So the same thing happens, right, in the car. If we want to, we will be checking the petrol and the diesel, right? So to reach to some destination, if you want to reach some Manali Shimla, so from Delhi to Manali Shimla, whether the car, petrol is sufficient or no, we are going to check that, right? In the same way, the Mars rover will be also checking the battery level, how it is, what it is, whether I can reach to the South Pole or no, whether I'm going to reach to the North Pole or no. These are the things where it is going to check. Then afterwards, what it is happening, the intelligent power planning will be happening. So can I drive further or I should wait? So how much long it will take, or should I reduce the movement to save the energy? These all things will be happening in this intelligent power planning. So this is all about this energy management. So again, what it happens, it will take the decision. If the power is low, we don't know, right? It will go, it will stand in one position. But afterwards, what it happens, in the South Pole only I'm getting the rock, but in the west side I'm getting good amount of soil. But I'm not able to travel because my already battery is drained. Regards to this rover, so what it is going to do if the power is low? What it does, it slows down. It stops driving first. Then it switches off the non-essential systems, which are not relevant. Or one more thing, what it will do is it postpones the science experiments and it enters to the lower, deeper mode. In the sleep mode, it goes. Then again, with the help of the sunlight, this gets charged. Then again, it will move to the west side and it will check the sand, how the sand is there. It is going to check. And the environment awareness is that the rovers will consider the sunlight availability and the temperature it is going to consider. So this is where the rovers will be considering. So the next is the science autonomy explanation. So here what it is going to happen, it will select the samples and it will analyze. Then what it does, it will scan the rover. That is what I can say is that it will scan the rocks, soils, as well as using the spectrometers. There is a special meters called as the spectrometers where they are going to analyze and it is going to detect the unusual patterns, the color, the texture, and the shapes of that. And the AI-based target selections will be happening. So it will identify and scientifically interesting features. What are the interesting features in the Mars? They are going to identify, and yes, this is all about the key features of this. What I can say is that the autonomous Mars rover. So the next one is the AI for space discovery, finding the new worlds. Right. So here what it happens, yes, obviously there are three, not one, new exoplanets are there, and there are still other planets also which are there, but NASA and those people are using those, and it has the 100x 1000x faster analysis. By using this AI models only, they can do everything very quick, very fast. Okay, so this is the thing where I can say, yeah, yes, there are so many new exoplanets and still they are discovering the new planets also. So this is the AI for the space discovery. Then, yes, the AI enhancing the Earth science and operations. Yes, AI is used even in that also for climate monitoring. The NASA will be using the AI ML to analyze the Earth observation, to analyze your the Mars observation, your the Chandrayaan, and your all this Aditya L1. So these all kinds we should see means it is the climate monitoring. So the climate monitoring is the best example for this. Then next we have this data discovery. Yes, obviously the datas are required, right? So here, what I can say is that whenever the images we are capturing or whenever the census datas, these all kinds of datas will be used. So here the NLP processing will be happening. The researchers will quickly find the relevant datas for this. Yes. And the next one is the mission operations. So here AI is used more for the automates spacecraft and health monitoring as well as for the mission scheduling. So in these all AI is also enhancing in the earth science and this operations. So yes, then next we have this the ISRO A. Right. So the even the AI is used in ISRO. It is used in ISRO. Yes, the AI is used in ISRO. Okay, we are going to see one small video, and after that, I'll complete this Chandrayaan, and that will complete my webinar. The video and audio is audible, right? Yes or no?
Yes, ma'am.
Okay, fine. And there is a one more video also for this. Just check. Okay, I guess you saw this video, right? So how the rover were going down and how it was taking and how in the Chandrayaan, how it was capturing the images and all. You saw right in the video? Yes or no? Or it was just for the time pass? Yes. Okay. So here in the yes, the ISRO is also using this AI. But yes, in the Chandrayaan 2, which was happened in 2019, so it got failed, right? Yes, it got failed. Why it got failed, Chandrayaan 2? What is the main reason to get failed? Any question? I mean, any answers? Why this Chandrayaan 2 got failed? During the final landing, it got crashed. Right. So what is the main reason is, yes, the landing issue, the landing problem. Yes, that is right. So here the velocity control error. Okay. So that is the one thing. That is the main reason. So the next one is the software and the algorithms issues were happening. Yes, it lost the control. Then next was the insufficient fault tolerance. The system couldn't recover once the things went wrong. Right. So the one more thing is obviously the hard landing, which has happened and it got crashed. Why it got crashed? Because they lost the communication 2 kilometers above moon. That is the reason where they lost the what I can say is that communication. So the what I can say is that Chandrayaan 2 got failed, but the Chandrayaan 3 became very successful in 2023, right? So how it is, the ISRO again learned the mistakes which they have done from this Chandrayaan 2. So what they have done, the key improvements, like it is like a simpler and a strong lander design. They have improved the braking and the descent control, and they have added the more sensors, as well as what is the role of this AI in this Chandrayaan 3. So the technologies which they have used is the autonomous navigation and the decision making. So the lander will decide how to slow down, where I need to stop. So these all kinds of things will be happening, and it will adjust the path in the real time. So it will not again rely on the earth commands, because you know the reason. If we start from the earth, so it will take hours together to reach, right? And where again it will get crushed. So that is the reason what they have done is they have used the A star algorithm, D star algorithm, Vijesha algorithm, Agis algorithm. So these all kind of algorithm they have used. The next is the hazard detection. So the cameras and algorithms can scan the lunar surfaces, that is in the Chandrayaan 3. It will also detect the rocks slopes, and it will select the safe land. Then next is the smart algorithm controls. So in the real time, it is going to check the velocity and as well as the correction, what has to be done. So these and other thing is that the software, proper software, they are going to use. And what is the simple comparison of this Chandrayaan 2 as well as Chandrayaan 3 is landing is weak, and in Chandrayaan 3 it is strong. Fault tolerance was very limited, but it was very high in Chandrayaan 3. So the autonomy is less in Chandrayaan 2, but in Chandrayaan 3 it was more. So the next one is the Aditya L1, that is, it was in the 2023, that is the solar observatory. Though mainly an observatory, it uses the AI-based fault detection as well as the autonomous system health management will be happening. Then after that, what are the future missions which is planned by the ISRO is that the Mangalyaan 2, that is the MON, which is expected to have more onboard autonomy and potential. The next we have is the Gaganyaan, that is a human space flight. Yes, even they are planning for this a human space flight. That is, the AI will help in crew support system as well as the fall detection. The next we have the ISRO NASA joint satellite mission, that is called as a NISAR, which will be in the 2024. The AI has been integrated for the Earth observation, and as well as we have AI in space robotics. ISRO is working for what? The Robo astronaut, that is a biomitra, which will be using AI for human robot and the interaction. Okay, so that's all from my end. So, is there anything to say